Once again I will reveal that it is a special type of diffusion. Special type of diffusion. Transport plasmolysis is also a special type of diffusion. So what is plasmolysis? So when it occurs, naturally the plasmolysis not occur in the plants. An exception, extreme water stress condition and salinity, the plasmolysis may take place. So the best example of plasmolysis is salting of pickles, preservation of fish and mutton by adding of salt is the best practical application of plasmolysis. So what is plasmolysis? The plasmolysis occur, the water come out from the cell and the cell membrane leave the cell wall, and protoplasm is shrink. When the cells are placed in hypertonic solution, when the cells are placed in hypertonic solution, the water come out from the cell and the cell membrane leave the cell wall and protoplasm shrink when the cells are placed in hypertonic. The shrinkage of protoplasm in hypertonic solution due to the loss of water from the cell, that is known as plasmolysis. So when the cells are placed continuously in hypertonic solution, thus completely the protoplasm shrink. Then it is called plasmolyzed cell. So when the cells are placed in hypertonic solution continuously, the plasmolyzed cells, the protoplasm is shrink. Such cells are called flaccid cells. In flaccid cells, the water potential is equal to solution potential, and the pressure potential is psi p is 0. In flaccid cells, the pressure potential is 0. So when the cells are placed in isotonic solution, there is no net causing of movement of water between the two systems. There is no change in isotonic solution. So when the cells are placed in hypotonic solution, it shows a reversible action to the plasmolysis. So when the cells are placed in hypotonic solution, the water moves into the cell. As a result, it creates some pressure. It exerted some pressure on the cell wall. As a result, the cells are turgid. So the pressure which is required for turgidity of the cell, that is called pressure potential. Turgor pressure. The pressure which is required for turgidity of the cell, that is a turgor pressure. In turgid cells, the pressure potential is positive. So when the plant cells are placed in hypotonic solution, the cells are turgid due to the endoosmosis. Because of the rigid cell wall, the cells are not break off. Whereas when the animal cells are placed in the hypotonic solution, because of the turgidity, it creates some pressure. As a result, at high turgidity, the animal cells are break off. That is the plasmolysis. At the same time, we discuss another special diffusion moment, that is imbibition. It is also a type of special diffusion. So what is imbibition? Increase of the volume of solids and colloids by observing the water, that is the imbibition. Increase of the volume of the colloids and solids. Increase of the volume of colloids and solids by observing the water, that is called imbibition. The best example is dry seeds and dry wooden pieces. Because of the imbibition pressure, the seedlings are come out from the soil and established in the soil. The imbibition pressure is vary from subject matter to matter. In proteins, high imbibition pressure is present, and whereas in starches, less imbibition pressure. So comparatively, in proteins have high imbibition pressure than starch. Hence, the proteinaceous seeds are germinate earlier than starchy seeds. So the imbibition also based on the concentration gradient. For the process of imbibition, it is necessary a concentration gradient difference between the absorbent and liquid imbibing is necessary. And also for imbibition, there is an affinity between absorbent and liquid imbibing is prerequisite. That we discussed in last class. Next, I will continue the topic long distance transport. Long distance transport in plants. So, whatever we discussed in previous classes, the process of the transport, diffusion, facilitated diffusion, water relation, water potential, imbibition, plasma, that is a shorter distance transports. So how the long distance for transport takes place in plants. So let me remember that. So you might have experimented at earlier classes. The plants, the twig of planted twig which bears white flowers, placed in color water. After few hours, the leaves are turned into color. The flowers are turned into color. A twig is placed in the color water. After few hours, the flowers are turned into color. If we examine the cut end of the stem, we will find the region where the substances are transported. The reason is vascular tissue, that is especially xylem and phloem. The transporting region is the vascular tissue, that is xylem and phloem. So when we examine the cut end of the twig, we will find a region where from the substances are transported. So the colorful region we will observe, that is region responsible for the transport of the substances. So particularly vascular tissue, that is xylem and phloem. Xylem is responsible for the transport of the water, minerals, hormones, chemicals. Xylem is associated for the transport of the water, minerals, hormones and chemicals. Whereas phloem is responsible for organic products, photosynthesis, and some inorganic solutes also transport through the phloem. Phloem is associated for the transport of the food material and inorganic material. Xylem is associated for the water, minerals, hormones, chemicals. So the diffusion is not account for the long distance transport. The diffusion is not satisfy the long distance transport. So the diffusion is not enough for the long distance transport. It accounts for over short distance transport. The diffusion, whatever we discussed in last class, one of the means the diffusion account for short distance transport. For example, the movement of the substance takes place by diffusion in the cell approximately So the substances are move across the cell. It takes place approximately 2.5 seconds to pass the cell, to cross the cell. By diffusion, the substances are move across the cell. It takes place approximately 2.5 seconds. Let me calculate how much time it require. How much time it require to move the substances up to 1 meter. 1 meter. Hence, the diffusion is not account for long distance transport. It is not satisfy the long distance transports. By diffusion, for example, the movement of the substances across the cell, it takes place 2.5 seconds. So let me calculate. So let me think about that. How much time it required to move the molecules or substances over 1 meter in the plant. So for long distance transfer. So generally, in complex organisms, the structure of the plants in complex organisms, the substances are to move for long distance. So here, in complex organisms, the production or absorption sites, and storage sites are far away each other. Two for each other. Hence, the diffusion and active transport not satisfy the long distance transport. So the production in the complex organism, the production or absorption sites and storage sites are far away with one another. Hence, the diffusion or active transport, you know that by consuming and by metabolic energy, the substances are moved. That is the active transport. So the passive movement is a diffusion. Diffusion and active transport is not satisfy the long distance transports in the plants. Hence, there is a need of a new system to transport the substances long distance as bulk and much high rate. There is a need of a new system to transport the substances as bulk and high rate. So because of the pressure difference between the 2 points, the substances are moved as bulk or en masse from one point to another point. In tall plants, for long distances, the substances are moved as bulk or en masse from one point to another point due to the pressure difference. So it is the character of movement of the substances. It is the character of the movement of substances as bulk flow. It is the character of bulk flow, move the substances as solutions. It is the character of bulk flow or mass flow to move the substances as solution or suspensions. Shift as a phase, the same phase as flowing river. In long distance, it is the character of the substance. Move as a bulk or en masse, whether it is a solution or suspension. Shift, move is the same phase as flowing river. As flowing river. Thus, the substances are move as bulk flow or en masse in long distance transport in plants. Long distance transport in plants. So the long distance transports, so the substances are to be moved long distance in the plants. The diffusion account for only shorter distance. For example, to pass the substances across the cell, it requires 2.5 seconds. Then we can calculate how much time it required to move the substance about 1 meter. So, in a complex organisms, the substances are to be transported long distance. The thing is, the production site and absorption site or storage sites are for each other. So there is a need of special transport system to transport the substances as a bulk at much higher rate per hour 15 meters. So it is the character, the substances are moved as a bulk flow or en masse due to the difference of the pressure gradient. Between 2 points. So the substances are moved as mass flow or bulk flow. Whether it is as a solution or a suspension, a shift, same phase as flowing river. Thus, the substances are translocate or transport long distance through the xylem. The long distance transport can be achieved. The long distance transport can be achieved by positive hydrostatic pressure. Positive hydrostatic pressure. The long distance can be achieved in the plants as a en masse bulk flow by positive hydrostatic pressure. Positive hydrostatic pressure means the garden pipes, the pipes which are laid in the garden, passed by the flow of the water without any pressure. So the garden pipes is best example for positive hydrostatic pressure. Or negative hydrostatic pressure. Negative hydrostatic pressure. The long distance transport can be achieved in tall plants, in complex organisms, by positive hydrostatic pressure and negative hydrostatic. Negative hydrostatic pressure, suction pressure. So by using the straw, when we suck the fluids, so this is the suction pressure. By suction pressure, the negative hydrostatic pressure, we use negative hydrostatic pressure to suck the water. So the long distance transports can be achieved by positive hydrostatic pressure and negative hydrostatic pressure. So how the water enters into the plant? So the root is responsible for absorption of the water. Because of that, we pour the water at the root, not on the leaves. We pour the water at the roots, not on the leaves. So the water enters into the plant through the root. The water enter into the root from the soil. The water enter into the plants through the roots into the plants. Because of that, we pour the water at the roots, not on leaves. So here the root hairs are responsible. Root hairs are responsible for absorption of mineral water and other chemicals. So root hairs. So on the root hairs are responsible for absorb the water. Root hair is a slender extension from epidermis of the root. Root hairs are slender extensions from the epidermis. The root hairs are absorb the water from the soil and enter into the water. Thus, the root hairs are responsible for the absorption of the water from the soil. So, so let me know the anatomy of the root and stem. So in the first year we discussed that, we learned that the anatomy of the root. So in this both root and stem, a special conducting tissue, xylem and phloem is present. The xylem is responsible for the absorption of the translocation of the water. The phloem is responsible for the food material translocation. So the roots are responsible for absorption of water. On roots, the root hairs are present, which are absorb the mineral water from the soil. The root hairs are slender extensions on the epidermis. Root hairs absorb water is enter into the deeper layers of the root. The root hair absorbed water is the water which is absorbed by the root hair. The water which is absorbed enters into the deeper layers of the root. So here the water is absorbed by diffusion. The root hairs are absorb the water by process of diffusion. So once the water absorbed by the root hairs enters into the root in the deeper layers, it enters the root in two methods. How the water enters into the root? The water enters in the root by two methods, two process. One is apoplast, another. How water enters into root. So the root hair absorbed water is entered into the root by two ways. One is apoplast. Second one is symplast. The root hair absorbed water enters into the deeper layers of the root. It enters into the root by two methods. One is apoplast, another one is symplast. Apoplast is the system which is continuous with the cell walls throughout the root. Apoplast is a system which is continuous through the cell walls throughout the plant. In apoplastic movement, the water moves through the intercellular spaces and cell wall. So in apoplastic movement, the cell walls. In apoplast system, the water is not cross the cell membrane. It is the apoplast is a non-living system. In apoplast system, it is a continuous with the cell walls. Throughout the root. So in apoplastic system, the water moves through the intercellular spaces along with cell walls. The thing is, the water is not water is not pass across the membrane, not pass through the cells and outside the cell. So the water pass, apoplastic movement takes place depending on the difference of the gradient. So here in apoplastic system also, the water moves according to the gradient, concentration gradient. It does not require any energy. Hence, in apoplastic system, the water moves continuously. When the water is evaporated into the intercellular spaces or outside the atmosphere, a continuous water stream is formed. A continuous water stream is formed. Thus, the water is continuously moved through the apoplastic system. What is apoplast? The root hair absorbed water enters into the deeper layer. The water enter into the deeper layer of the root by two methods. One is apoplast, another one is symplast. Apoplast is a continuous system with the intercellular spaces which is present throughout the root, throughout the structure of the root. In apoplastic system, the water moves through the intercellular spaces along with the cell wall. Here, the water is not cross the cell membrane. Water is not cross the cell membrane. In apoplastic also, the water movement is take place based on the concentration gradient. As the water is evaporate into the intercellular spaces or outside atmosphere, a continuous water stream is formed. Thus, the water is continuously flow through the apoplast. Next, symplast. Symplast is a system connected with the cytoplasmic strands. Symplast is a system which is connected with the cytoplasmic strands. The neighboring cells are connected with the plasmodesmata. In symplastic system, it is a system which is connected with the cytoplasmic strands. The neighboring cells are connected with the plasmodesmata. In symplast system, the water passes through the cells. In symplast system, the water passes across the cells or membrane. The water passes across the membrane. So here in symplast system, the water passes through the cells, and the movement of water is slow. In symplast system, the movement of water is very slow. Here is a small break. We come back within 2 minutes.
విద్యార్థుల భవిష్యత్తుకు బాటలు వేస్తూ మునుపెన్నడూ ఎరుగని అత్యుత్తమమైన ఫలితాలతో అద్భుతమైన విద్యా ప్రమాణాలతో ముందుకు దూసుకుపోతోంది శ్రద్ధ జూనియర్ కళాశాల. మహబూబ్నగర్ జిల్లా కేంద్రంలో ప్రముఖులు అనుభవజ్ఞులైన చైర్మన్ జగపతిరావు ఆధ్వర్యంలో 2011లో స్థాపించబడిన మా శ్రద్ధ జూనియర్ కళాశాల ఉన్నతమైన విద్యా ప్రమాణాలతో ఇంజనీరింగ్, మెడికల్లో చక్కని ర్యాంకుల సాధనలో విజయం వైపుగా కృషి చేస్తోంది. ఇంజనీరింగ్ అయినా, మెడికల్ అయినా శ్రద్ధ జూనియర్ కళాశాల విద్యార్థులదే పై చేయి. ఇంటర్తో పాటు ఐఐటి, నీట్, ఎంసెట్ నందు లాంగ్ టర్మ్ ప్రోగ్రామ్స్ ద్వారా కార్పొరేట్ కళాశాలలో 20 సంవత్సరాల అనుభవం కలిగిన అధ్యాపక బృందంచే ప్రత్యేక శిక్షణ తరగతులు నిర్వహిస్తూ డైలీ ప్రాక్టీస్ పేపర్స్, వీక్లీ టెస్ట్, కౌన్సిలింగ్ ద్వారా విద్యార్థుల నైపుణ్యం మెరుగుపరచడం మా ప్రత్యేకత. హ్యాండ్బాల్, ఫుట్బాల్, క్రికెట్ లో మా విద్యార్థులు జాతీయ క్రీడాకారులుగా గుర్తింపు పొందుతున్నారు. జిల్లా కేంద్రంలో సొంత భవనాలలో కళాశాలలు, విద్యార్థులకు ఉదయం, సాయంత్రం వేళలో స్టడీ అవర్స్, ఐఐటి, నీట్ లో ప్రముఖుల నిపుణులచే విద్యా బోధన, బాలికల కోసం ప్రత్యేక క్యాంపస్, ఎంపీసీ, బైపీసీ గ్రూప్లతో కో ఎడ్యుకేషన్, ఎంపీసీ, బైపీసీ, ఎంఈసీ, సిఈసీ గ్రూప్లతో గర్ల్స్ క్యాంపస్, ఎంపీసీ, బైపీసీ గ్రూప్లతో పాటు ఐఐటి, నీట్, ఎంసెట్లతో అకాడమీ.
I am Mariam Makbul. I passed out from Shraddha Junior College in 2017 from BPC. Currently, I have passed out from Tata Institute of Social Sciences. I finished my bachelor's. So one thing which is very striking about this institute is the immense and genuine amount of effort that the team of faculty puts and takes up for the success of students and their prosperity. And another thing that is very remarkable about this place is they ignited in me the spirit of competitiveness, which is very necessary in this globally evolving market world. There was one Sanskrit slok which which I learnt when I was very young. Udhyame nahi siddhyanti karyani na manorataihi nahi suptasya simhasya pravishanti mukhe mruga. This means you cannot just achieve anything just by thinking of it. You need to put in effort. That is what I have learnt from this institute. Like even though king of jungle, it has to hunt for its own prey, which is what I have learnt from Shraddha Junior College.
I am Uday Kiran. I have completed my intermediate in Shraddha Junior College in 2019, and I have completed I have joined Srinidhi Institute of Science and Technology, and I scored my JEE Mains percentile as 98.19, and due to some other problems I didn't join NIT, and I have scored my MCET rank as 4500, and here the lecturers take the special care with each and every student.
సీనియర్ మరియు జూనియర్ ఇంటర్ అడ్మిషన్ల కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల కో ఎడ్యుకేషన్ క్యాంపస్ మెట్టుగడ్డ. మీరు సంప్రదించవలసిన మా ఫోన్ నెంబర్ 9494430200. ప్రత్యేకమైన గర్ల్స్ క్యాంపస్ కోసం సంప్రదించవలసిన మా చిరునామా ఆపోజిట్ పంచవటి హోటల్ న్యూ టౌన్ మహబూబ్ నగర్. మా ఫోన్ నెంబర్ 7337294653. ఐఐటి నీట్ అకాడమీ కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల మెట్టుగడ్డ. మా ఫోన్ నెంబర్ 9491629962.
Yes, welcome after the break for continue the class. So here we are discussing the methods of the process of entry of the water into the deeper layers of the root. It takes place by two methods. One is apoplast, another one is symplast. Apoplast is a continuous system which is by intercellular spaces and cell walls. Here in apoplast, the water pass through the intercellular spaces along with the cell wall. So here we have to remember that in apoplast the water is not passed across the membrane, not passed through the cells. It just outside the cell, that is intercellular spaces and cell wall. So the apoplastic movement takes place based on the concentration gradient from high concentration to low concentration, high concentration to low concentration. So as the water is evaporate in the intercellular spaces, a continuous water stream is formed in the tissue. Thus the water is continuously moved through the apoplast, So symplast system, the another type of system, process of the entry of the water into the root, symplast. It is a living system. Apoplast is a non-living system. Symplast is a living system. The symplast system which is formed by the symplast system which is connected with the cytoplasmic strands. The neighboring cells are connected with the plasmodesmata. In symplast system, the water pass through the cells. In apoplast, the water is not passed through the cells. In symplast, the water is passed through the cells. So here in symplast system, the water pass through the membrane, across the membrane. The water moves across the membrane. Hence, symplast is slow process. In symplast, the water moves very slow. So at in the cross section of the root, at endodermis, the endodermal cells are, because the endodermal cells are suberinized with the Casparian bands. Hence, the water is passed through the endodermis by symplast. Only except endodermis, the remaining in plant, the water moves in apoplast. At endodermis, the water moves in symplastic method. So throughout the structure of root, the water moves apoplast method. Why? Because the cortical cells are arranged very loosely. In plant, the complete water moves by apoplast because the cortical cells are arranged very loosely. Hence, the water moves apoplast. At endodermis, the cells are become thick by the cells are suberinized with the Casparian strips. Hence, the water is not passed through the apoplast by apoplast. So at endodermis, the water is diverted to non-suberinized cells. At endodermis, the water is directed to non-suberinized cells, that is the passage cells. So through the passage cells, the water passes through the cells by symplast. At passage cells, the water is moved by symplose. It enters into the endodermal cells, passage cells, and then it enters into the xylem. Thus, except at endodermis, in total root system, the water is moved by apoplast. So after enter into the xylem, again it is apoplast. Why? Because it is a non-living conductus. The xylem, in xylem also the apoplastic movement takes place. Why? Because xylem also a non-living conducting tissues within intracellular spaces. Hence, the water moves by apoplast in xylem. In some of the plants, the water absorbed by some associate structures. In some of the plants, special structures are associated for absorption of the water. In some of the plants, some special structures are associated with the plants. So, example, mycorrhiza. Mycorrhizal roots. In some of the plants, some of the structures are associated for absorption of the water. In some of the plants, special structures are associated to absorb the water. One of the example, mycorrhiza. The fungal hyphae, the fungus associated with the roots of higher plants is called mycorrhiza. What is mycorrhiza? The fungus associate with the roots of higher plants. Roots of higher plants is called mycorrhizae. It is important for short answer. What is mycorrhizae? Fungus associated with the roots of higher plants is called mycorrhizae. The fungal hyphae form a network around the root system or penetrate into the roots. Mycorrhizal roots, the fungus may form network around the root. Sometimes the fungal hyphae penetrate into the roots, which has large surface. The fungal hyphae which having the large surface to absorb the soil water. So the fungal hyphae absorb more water. Perhaps root is not done. So more than root hairs, the fungal hyphae which is extend and having the larger surface area, so which absorb the more soil water, which is not by the root hairs. Thus, the fungal hyphae absorb mineral water to the plants. In turn of that, plants are provide the food material and nitrogen containing compounds to the fungal hyphae. Thus, a symbiotic association with the higher plants and fungus. It is the best example for symbiotic association. So, some of the plants are obligative mycorrhizae. Some of the plants are obligative, compulsory. Without fungus, the plants cannot establish. The plants cannot survive. For example, pinus. In some of the plants, it is obligative. Example, pinus. Pinus seeds are associated with the fungus. Without association of fungus, the pinus seedlings are not established and developed. In pinus plants, it is an obligative association. The fungus seedlings are not established without fungus. So, a diagrammatic representation is there, the movement of water into the root. A diagrammatic representation is there. So, how the water moves into the root. This is the root hair, cortical cells. This is the endodermis, which is impervious to water, then primary xylem or protoxylem. So the water is absorbed into the root here by diffusion. The absorbed water which pass through the epidermal cells and through cortical cells as symplast through the intercellular spaces. At the endodermis, the water passed through the symplastic method, through the endodermis by symplastic method, and then enters into the xylem by apoplast. This is the movement of. So through the cells it is the symplast, through the intercellular spaces apoplast. The water moves through the cells, this is the symplast. The water moves through the intercellular spaces along the cell wall, that is the apoplast. This is the way of water movement in root by apoplast and symplast method. Then how water move up in plants. Transport of water up in plants. How water move up in plants, or transport of the water up in plants. So the water which enters into the root, it has to be moved up in the stem. Whether it takes place by active movement or passive movement. Is there any energy requirement for the upward movement of water? Is there any force? What is the driving force for upward movement of water in the plants? So the water enters into the root, and the water enters into the root, then it moves up in the stem. So is it by passive method or active method? What is the driving force to upward movement of water into the stem? Is there any energy required? So let me discuss one by one. So first one is root pressure. One of the generating force is root pressure. So as the mineral ions are enter into the cell, enters into the root cell, it follows the water potential. Then a pressure is created. Exerted on the cell wall. The pressure which is created in the cell by observing the minerals, that is called root pressure. A positive pressure which is developed in the cell by observing the minerals. As the different types of minerals are enters into the cell, it creates some pressure. The positive pressure which is created in the cell, that is called root pressure. Root pressure is enough for moderate push of water, enough to push the water at moderate heights. The root pressure is which is help the moderate push. The root pressure which is help in moderate push of the water in the root pressure which is help to push the water moderate height to some extent height. The root pressure which is help in push the water at moderate height to some extent. So we can witness the root pressure in the plant. We can witness the root pressure. What is root pressure? As the different minerals are absorbed enter into the cell, it creates some pressure. That positive pressure is nothing but root pressure. Root pressure is help to push the water at moderate rate, to push the water to some extent. The root pressure we can witness in the plant. We can witness in the plant. Just take a soft stem plant in the morning, where the atmospheric moisture is more, and cut the stem horizontally with the blade. So from cut end of the stem, some substances ooze out because of the root pressure. So root pressure we can witness in the plants. Just take a soft stem plant, select a soft stem plant. So in the morning, where the humidity is high in the atmosphere, just cut the stem near to the base, cut the stem horizontally near to the base with sharp blade, and immediately some substances are ooze out from the stem because of the root pressure. If you connect the cut end, a rubber tube, its sleeve, we can measure the pressure of the root. We can measure the exudation of the pressure of the root, and we can analyze the exudates, chemical analysis of the exudates. So we can witness the root pressure in the early morning or in the night, during the cool night. So when we go outside, we can witness the root pressure. So in grasses and herbaceous plants, the droplets are formed. Along the margin at opening veins. So even we can witness the root pressure in the cool night and early morning. The water droplets are formed along the margin and at the apex by opening veins. So loss of water, formation of water in liquids through the opening vein, that is called guttation. Because of the root pressure, the guttation process is taken. What is guttation? So secretion of the water as liquids along the margin or at the apex of the leaf blade, that is called guttation. Guttation is because of the root pressure. What is root pressure? One of the process to upward movement of the water in the stem, that is root pressure. As the minerals enter into the cell, it creates some pressure. The positive pressure which is developed in the root cells, that is called root pressure. Root pressure help moderate push of the water to some extent in the plant. So we can witness the root pressure in the plant. Just to select a soft stem plant in the morning, temperature, the humidity is high, just cut the stem near the base. Immediately some substances are ooze out from the cut end of the stem. So that because of the root pressure, if you connect the rubber tube, sleeveless, so you can collect the secretions and measure the root pressure, and also we can analyze the exudates. So the root pressure we can witness in the atmosphere also, in the nature also, in the cool morning or in the night. In the night, the water is formed as water droplets from opening vein ends along the margin and apex of the leaf blades. Secretion of water as a liquid droplets. Secretion of the water as a droplets from opening vein in the leaf lamina or along the margin of the lamina and apex is called, the phenomenon is called guttation. Guttation is a 2-mark question. So just a secretion of the water as a water droplets from opening vein is called guttation. So root pressure can at best to push the water at moderate height, but it is not enough to translocate the water for long distance. Root pressure can at best to push the water at moderate height, but it is not enough for long distance transport. The root pressure can help to continuous the water streams, water columns which are broken by the transpiration or tension. Root pressure which can help to form the continuous water streams in the xylem capillaries, which is broken by enormous pressure. So hence the root pressure is not enough for upward movement of water in tall trees. So in tall trees the upward movement of water takes place by another process by transpiration pull. In tall plants, the upward movement of water takes place by transpiration pull, which generates which is the driving force. Transpiration pull is a driving force for upward movement of water in tall plants. Example, Sequoia sempervirens. Sequoia, it is a gymnosperm which grows 100 feet or 300 feet. In such plants, the upward movement of water takes place by transpiration pull. It is a driving force. So because of the adhesive and cohesive forces, the water is driven upward by transpiration pull. So it was proposed by Dixon, cohesion tension theory. Let me discuss the transpiration pull. Despite of hot and circulatory system, the water is move upward in the tall plants with high rate, that is 15 meters per hour. In tall plants, the water is move up despite of hot and circulatory system. The water is move upward in the plants, tall plants with high rate, that is 15 meters per hour. There is a long standing question whether water is pulled or pushed. So all the researchers agreed that the water is pulled in the plant. So the water is pulled in the plant because of the adhesive cohesive force. It pulled upward. A continuous, as the water is evaporate into the atmosphere, a tension is created. That is help in transpiration pull. So the tension, as the water evaporates into the atmosphere, a tension is created in the leaf atmosphere. That is a driving force for transpiration pull. So the plants are utilize 1% of water only for photosynthesis and growth. So as the plants absorb water, only 1% is utilized for photosynthesis and growth. The remaining water, which is lost into the atmosphere through the stomata, through the stomata into the atmosphere. The loss of water as water vapors from aerial parts of the plant is called transpiration. Transpiration. The loss of water as water vapors from aerial parts of the plant, that is called transpiration. So the ascent of xylem sap against the gravity force, the transpiration pull is help for ascent of xylem sap through the stem. So the ascent of xylem sap is helped by following three physical properties. The ascent of xylem sap through the xylem is helped by the three physical properties. That is the coercive force, adhesive force, and transpiration. Ascent of xylem sap through the xylem in the stem is by three physical properties: coercive force, adhesive force, transpiration pull. Coercive force means mutual attraction among the water molecules. Mutual attraction between the water molecules. So attraction to the polar surface. Attraction to the polar surface. The water molecule attract with it to the polar surface. Transpiration pull is the driving force. Transpiration is a driving force. Transpiration is a driving. So the ascent of xylem sap in the stem is achieved by the three physical properties, which is carried by the three physical properties: coercive force, adhesive force, transpiration. Coercive force means mutual attraction of the water molecules. The water molecules are attracted with one another, and attraction to the polar surface. The water molecule attached to the polar surface of the xylem vessels. And transpiration. Transpiration is a driving force. Driving force to upward movement of water. These three physical properties are create high tensile strength, which is ability to resist the gravity. These three physical properties create high tensile, that is ability to resist gravity, and high capillarity, high tensile, high capillarity. The water columns, water in capillarity, the capillarities are aided with xylem